So this section is about solving chemical problems. Most of the problems we're going to run into in the course are actually unit conversion problems. There are other problems that will require using specific equations. But I want to teach you a method for solving unit conversion problems. It's called dimensional analysis. This is, I think, the most important thing I learned in high school. I learned this technique as a junior in physics class, and I've used this way more than anything else I learned in high school. Just a note about units, so we should always include them in calculations. They get multiplied, divided, and canceled just like any other algebraic quantity. So like x times x is x squared. Centimeters times centimeters is centimeters squared. They work the same way. So what we call a unit equation is a statement of two equivalent quantities. So 2.54 centimeters is equal to 1 inch. You take a little piece of paper and you measure it with a ruler, an English ruler or a metric ruler. One of them is going to tell you 1 inch and the other is going to tell you 2.54 centimeters. They're different names for the same length. From that unit equation, we can make a conversion factor, which is going to be a fraction. So we can do that like this. 2.54 centimeters is equal to 1 inch. If I divide both sides of that equation by the same thing, it's still equal. So I'm going to divide both sides by 1 inch. What is 1 inch divided by 1 inch? It cancels out. It's just 1, right? Those cancel, this is equal to 1. So that means that 2.54 centimeters per inch is numerically equal to 1. Which means that if I multiply something by 2.54 centimeters over 1 inch, I'm not actually changing the length, I'm just changing the units. We can make the other, there's always two conversion factors, we can make the other one by dividing by 2.54 centimeters instead. And now that side cancels out. And 1 inch over 2.54 centimeters is also equal to 1. So, if I invert 1, it's still 1. If I invert this, I get that, which is still 1. So most unit conversion problems, you're going to start with a unit, and then you're going to have to apply some conversion factors, and then you're going to end up with a different unit. So your given unit, you're going to multiply by a conversion factor, and we'll set that up so that the desired unit is on the top and the original unit's on the bottom. Those units are going to cancel out and give us the desired unit. So let's do an example. How many centimeters are in 12 inches? So I have 12 inches, and I'm going to multiply by a conversion factor. Well, we just looked at the two different ones. So I want inches to be in the denominator and centimeters to be in the numerator, because then my units are going to work out. I'm analyzing the dimensions, the units. I want inches to cancel out, and I want to be left with centimeters. So that tells me I'm using this version of that conversion factor. So 12 times 2.54. Calculator says 30.48 centimeters. We're going to sneak sig fig review in all over the place. How many sig figs should that answer have? 2. So this conversion is exact. So how many sig figs does 12 inches have? 2. It kind of looks like an exact number, right? Because it's a whole number. But it's only going to be exact if those are discrete objects that can be counted. So this has 2 sig figs to start with, so it should end up with 2 sig figs. So we could call that 30 decimal point centimeters, or 3.0 times 10 to the 1 centimeters, to be clear about our sig figs. So, for those of you that like steps and lists, here's a list of steps. How to solve problems. So first of all, you need to identify the starting point. What are you being given? Write those numbers down with their units, and remember that per units, like grams per cubic centimeters, might be used as conversion factors. We'll see some examples of that. Identify the end point. Where are you going? And then devise a way to get from the starting point to the ending point. So I asked last night, and I hope the answer is still the same. Did you guys watch Dora the Explorer when you were little? Or at least have seen it? A lot of you have. So Dora was always, trying to go somewhere, and who do you call when you don't know which way to go? The map, right? And the map would come in, and they say, well, if you want to get to the snowy mountains first, you have to go over the scary bridge, and then through the pretty flowers, and then you get to the snowy mountains. And then they would chant that, right? And then they would go on their little trip. That's what we're going to do here, okay? You have to know where you're starting, and you have to know where you're going before you can come up with a way to get there. So we're going to devise a plan. You might have to look up some conversion factors. This step, figuring out the plan, that's the hardest part. Once you've got that part, the rest is just going to follow a pattern. It's going to be follow the pattern. It'll be the same every time. So once you've got your plan, then you're going to solve it by following the plan. Use a calculator. Don't try to do math in your head. Or if you really like doing math in your head, check your work with the calculator, please. Do it twice on the calculator. Just the other, I don't remember if it was you guys or the other class. I did something wrong on my calculator, got the wrong answer, right? Well, if I do it twice, usually those errors are, just a mistake, kind of a random mistake. I press times instead of divide. If I go through and do it again, I'm probably not going to make the same mistake, right? So if I get 2 different answers, that tells me I'm making a mistake somewhere. So then we go for best 2 out of 3, right? And hopefully it doesn't go any further than that. And then at the end, look at your answer. Does it make sense? If you're calculating that this person is 7 meters tall, doesn't make sense, right? Sometimes you look at the answer and you're like, I have no idea if that makes sense or not. But other times you can say, yeah, there's -5 molecules in this bucket of water? What? That's not possible, right? And then also check that the units are correct. Okay, so that's the strategy we're going to use. So this first one is going to start out with very few words. The more story that gets in there, the more you have to think about it. So convert 288 centimeters to yards. What are they giving me? Centimeters. And what are they asking me for? Yards. Okay. So I'm going to write down the stuff they gave me. Here is just the one thing, 288 centimeters. I'm trying to go to yards. So I'm going to put that over at the other end of the map. And now I have to figure out how to get from centimeters to yards. There's more than one way to get there. If I want to go to Sacramento, I could head south and go all the way around the world and come from the other side, right? It would work. It would take an awful long time. Or I could just head north on the freeway and be done with it. So some of these paths are going to be more direct, and some are going to be less direct, but you have to take a path where you know or can find the conversion factors. Now, on the worksheet, there are several problems that are set up to be multiple steps. And I actually tell you, these are the steps, you have to do the steps, because otherwise you don't learn the method. So we've got centimeters, which is a metric unit of length, and we have yards, which is an English unit of length. And so we have to somehow bridge that gap. What can we do in between? We could go to inches, right? Because we just talked about converting centimeters to inches. So I'm just going to jot this down over here so I don't forget. And then from inches, someone said we can go to yards. We can, if we know how many. How many inches in a yard? 36. Cool, we'll do it that way. What if we don't know? You could go to feet and then to yards. Okay, so there's our path. We're starting at 288 centimeters. We're going to go to inches, and then we'll make it to yards, right? Just the map on the Dora map. Yeah. Okay. Now what we're going to do is we're going to write the equation. We're going to do all the math in one equation and punch it through on the calculator. So I'm going to copy down my first number and unit again. I'm going to look at my path and see how many arrows are there. There's 2 arrows. That means I need 2 conversion factors. So I'm going to write in those 2 conversion factors. Just a space for them. Okay? A blank for every arrow. And then just like Dora, chanting where she's going to go, centimeters to inches to yards, centimeters to inches to yards. We're just going to copy those units down on the tops of those fractions. I need this unit centimeter to get canceled out. I need it to go away. So I'm going to take that centimeter and I'm going to put it in the denominator of the next term so that I have centimeters divided by centimeters. Poof, they're gone. Now I need to get rid of inch. I'm going to do the same thing and put an inch down here. Poof, they're gone. I'm left with yard, which is the unit I want to find. Okay. So we're going to put the units in and get the units to work out first, and then we'll put the numbers in. Okay? It just makes it a lot simpler. We don't have to think, is that bigger? Should I multiply by this number or divide by this number? The units are going to tell us exactly what to do. So here we have the conversion factor for inches and centimeters. I wrote down the unit equation over here in case we've forgotten. So we need the top of this to be equal to the bottom of this, right? So on the top is inch, so 1 inch, right? 1 inch is equal to 2.54 centimeters. The number stays with its unit. You don't switch them around. And then the other one, I didn't specifically write down, but 1 yard is equal to 36 inches. So here, what number goes on top with yard? 1. And on the bottom, 36. Very little thinking, right? So now you pull out your calculator, and we're not going to do all of the numerators and all of the denominators and then divide them. We're going to start at the left and just work our way across, and that way we don't have to write any intermediate values down. Every time you write a number down, you could do it wrong. Every time you take that written number and punch it back into your calculator, you could make a mistake. So just do it all at once. So I'm going to take 288, I'm going to multiply by the number on top, divide by the number on the bottom. Multiply by the top, divide by the bottom. Well, if I skip the times 1, is it going to change the answer? No. So you can skip the times 1. Other people are like, but I can't skip the times 1 because it's written there times 1. Well, go ahead and multiply by 1 because that's what makes sense to your brain. That's how you think. So go ahead and do it. So I'm going to say that I'm doing it, and I'm not actually going to do it. So 288 times 1 divided by 2.54 times 1 divided by 36 equals And then as I start writing down my numbers, I realize, I'm not going to need all of these, right? How many sig figs in my original number? 3. These conversion factors are both exact. And what that means is we can ignore them for significant figures. I started with 3, I'm going to end with 3. So I'm going to write down the first 3 digits and underline that one. And I'm going to write down the next 2 digits and then the unit. Then I'm going to go back and round it and say the answer is 3.15 yards. I want to write this part down because on the next page I might find out that I need to go back and use that number in another calculation. If I have 2 extra digits, I don't have to worry about rounding errors.
The sig fig, would it be 2? Is that 36?
That's a good question. But this is exact because it's within the English system. A yard is exactly 36 inches by definition. Yeah?
And we have to write all that instead of like, oh, there's that many yards and that there's that many centimeters in a yard. We can just figure it out.
So what do you have to write down?
Like
This part
steps.
and this part. That's showing your work. At the beginning, before this makes any sense to you, you should write this down. And you probably should write these down too. But very quickly, you won't need to do that anymore. Because, do we really need to chant the 3 steps? We can remember that. Now, if it was 10, maybe we'd have to write them down. You turn left at the 7-Eleven, and then you go 2 miles, and you've got to write that stuff down. But not something like this. But that's the minimum you should write down to show your work. Good question. Good question. Any other questions? Yes. Oh, wait. No. Just a finger in the air. I keep imagining things. I'm going to skip that one. So what about those metric units? The prefixes in the metric units make it very easy to create unit equations or conversion factors. So here, if we want to find a conversion factor between kilometers and meters, well, 1 kilometer is 1 times 10 to the what? 3. Because everybody agreed, I know they didn't ask us, but the rest of them agreed, that k, lowercase k, stands for 10 to the 3. So you just write that in. If it was grams or liters or any other unit, works the same way. So the way I'm showing you, the prefix goes on one side and the multiplier on the other side, never together. So if you memorize the prefixes and they're 10 to the somethings, you put the prefix on one side of the equal sign or the fraction line, you put the 10 to the something on the other side, you never ever put them together. So using this method, if we're converting between centimeters and meters, 1 centimeter equals 1 times what? 10 to the minus 2, because that centi stands for 10 to the minus 2. Well, 100 centimeters is equal to 1 meter. Also true. I'm not going to do them like this in front of the class because that gives you the idea that you can just not follow that rule. Because now I have a number and a prefix together. So if you're good with units and you want to do it like that, you're fine. But you didn't really need all this explanation then. But a lot of students, it's just been a struggle because it just never quite made sense. Once you see how it works, then it's easy to remember. We just have to push through until you see it. So I'm not going to do it that way, but you can do it on your paper. I will recognize that that's correct and that's fine. But what I'm teaching you is the prefix on one side, the multiplier on the other side, never together. Okay? What if we're converting to, say, centimeters to nanometers? So now both of the units have prefixes. There's 2 prefixes. I want you to do this in 2 steps. So to do centimeters to nanometers, we're first going to go from centimeters to meters, and then we're going to go from meters to nanometers. There is a relationship between centimeters and nanometers. But how often are we going to use that? I could derive it, but that is too much thinking, and I'd rather save my brain for other things. So I'm just going to do these 2 fast and easy steps instead of trying to do a shortcut that might lead me in the wrong direction. So if you have 2 prefixes, do 2 steps. Let's do one with 2 steps. So convert 5.52 times 10 to the minus 5 centiseconds to microseconds. So both of these have prefixes. So again, whether actually writing it down or not, we're identifying that this is what I'm starting with, and this is what I'm going to. So I'm going to start with 5.52 times 10 to the minus 5 centiseconds. And I'm going to microseconds. What I'm going to do is I'm going to go to just naked seconds in the middle without a prefix. So I'm going to do it in 2 steps. So 5.52 times 10 to the minus 5 centiseconds. How many arrows? 2. How many fractions? 2. Here's my units. Centiseconds, seconds, microseconds. Centiseconds, seconds, microseconds. This unit goes in the bottom of the next one, so they cancel out. And this one goes in the bottom of the next one, so they cancel out. You could do this with 15 steps. It's all the same. All the units are in, and now I'm going to put the numbers in. So let's just write this down. What does centi mean? 10 to the negative 2. And micro means 10 to the negative 6. So on this first one, the prefix is on the bottom. So I'm going to put what it means on the other side. 10 to the minus 2. And you could leave it like that. But sometimes we just really want to see a number on both sides. And so this would be per 1 centimeter. And it might help you entering this into your calculator if you have it as 1 times 10 to the minus 2. Over here, the prefix is on the top. So where do I put the 10 to the minus 6? On the bottom. I'm never going to put them together because this is like a nickname for this. You don't use someone's full name and their nickname. You use one or the other, right? So we're going to have the prefix or the multiplier. One on one side, one on the other side. So I'm going to have 10 to the minus 6 down there. So 1 microsecond is 1 times 10 to the minus 6. So did we do EE buttons on the calculator? No. I'm remembering yesterday. But even when I'm only teaching one class, I sometimes remember like 2 years ago. I distinctly remember. Okay. So how do we enter scientific notation like this on our calculators? Your calculator has a special button for that. Most of them use EE or EXP. and some of them use times 10 to the x. Those buttons stand for times 10 to the. So to enter this number in my calculator, let's do a different color here. I'm going to press 1, and then as I push that EE button, I'm going to say times 10 to the, and then negative 2. Now my calculator has an EE button. When I press EE, it only shows me one E, which makes some people think, well, it's supposed to be EE, I need to do that again. No, it's just one. And your calculator is going to display this to you differently depending on what kind of calculator you have. So to do this calculation, I'm going to have 5.52 EE times 10 to the negative 5. And then I'm going to multiply. I'm multiplying by the top. I'm dividing by 1. I'm multiplying by 1. And then I'm dividing by 1 EE negative 6. I'm pressing equals. This negative might look like a negative sign in parentheses. It might look like a plus minus button. Some calculators actually use the subtraction button. Others have a special button. You just have to figure out what yours wants. So we do this, 5.52 EE negative 5 times 1 EE negative 2 divided by 1 EE negative 6 equals 0.552, oops, microseconds. How many sig figs did our starting number have? 3. And how many is our calculator showing us for our final answer? 3. Metric conversions are all exact, and all they're doing is moving the decimal point around. And some of you may say, well, can't I just do that in my head? I'm just adding and subtracting exponents. Sure, go for it, but don't confuse the rest of us. So if you did not get your calculator to say 0.552, then call me over later and I will have a word with it. Because it's always the calculator's fault. It's not your fault. Any questions about that one? Sometimes we have units raised to a power, like for area or volume. Volume is, centimeters cubed. When building conversion factors for units raised to a power, raise both the number and the unit to the power. So here we're going to make a relationship between square inches and square centimeters. If you go to look in a table of conversion factors, it's not going to show you this one. It's going to show you centimeters and inches, because that's all you need. So you start with the unit without the square. You write that down. And then we're going to square both sides, all of it. So the number and the unit. So that's 2.54 squared, centimeters squared. 2.54 squared is 6.45 centimeters squared. Over here, we're squaring the 1, but it's still 1. And so that kind of messes people up sometimes because, well, we didn't square the 1. Well, yeah, you did. It just was the same because 1 is annoying that way. And so then this is the relationship between square centimeters and square inches. If it's cubed, you cube them. So let's do this one. How many cubic centimeters are there in 2.11 cubic yards? So we're given 2.11 cubic yards, asked to find cubic centimeters. 2.11 cubic yards. I'm trying to get to cubic centimeters. When I'm making my path, I'm going to pretend that the 3 isn't there. Well, how would I do yards to centimeters? So yards to inches to centimeters. So if we're doing this cubed, then the inches are also cubed. So let's write down those relationships over here. 1 yard is how many inches? 36 inches. And I have to square both sides. So 1 square yard is equal to 36 squared inches, which is 36 times 36, 1296 square inches. Yeah, you're right. I need cubed because, thank you. I was just testing you. No, I wasn't. We need to cube this. And what I hate is when I do the whole problem wrong. And then they say, oh, but could you tell me right away? So thank you very much for telling me right away.
I thought maybe you were gonna multiply again one more time.
Yeah.
after that.
Yeah, so I already got 36 times 36 and it's times 36. There's different ways to do it on your calculator. So we're getting a really big number here. When it's written like this with the number and the inch inside of parentheses and an exponent on the outside, then we're cubing all the things inside the parentheses. Over here, now sometimes people will say, well, don't I need to cube the number too? No, we already did that. The way this is written, only the inch is cubed. This is just the number, okay? So there's one relationship, and then we also need inches cubed to centimeters cubed. So we'll start with inches to centimeters. And I'm going to cube them, not square them. So 1 cubic inch, so 2.54 cubed, (16.387064) cubed. You could also put into your equation 2.54 cubed centimeters cubed and do the cubing as part of your calculation, whatever makes more sense to you. So we're using this guy and this guy. So we've got our path, we're just going to follow the path. 2.11 cubic yards. I have 2 arrows, so I have 2 fractions. We'll do one more here. Yeah, sorry.
Could we go back and look at how to convert centimeters to Fahrenheit to centimeters?
Degrees Celsius, you
Yeah.
mean?
I'm sorry, I'm doing.
That's okay.
Okay. Yeah, at least.
Let's talk about that when we're working on the worksheet, okay? So this is a story problem. A vineyard has 145 acres of Chardonnay grapes. A particular soil supplement requires 5.50 grams for every square meter of the vineyard. How many kilograms of the soil supplement are required for the entire vineyard? Does that sound like it might actually be a practical question if you were growing grapes? This is a real world kind of problem, at least here in the Central Valley. I mean, there's grapes all over the place. Okay, so the trick is taking all of these words, the story, and making it into a math equation. So we're just going to apply that strategy. We read the problem. Now I'm going to highlight the numbers. So we've got 145 acres. Do we care what kind of grapes? No, we don't. And here I have 5.5 grams for every square meter. That's kind of a tricky way of saying it, but there's that whole thing is the unit, right? Grams for every square meter. Normally we'd say grams per square meter. And then they give us this thing at the end, which is just them being kind. So we don't have to go look that up. And then what we want to know is kilograms of soil supplement. Okay, well that didn't help very much. Oh, just you gotta keep going with the plan here. I'm gonna make it purple, even though Chardonnay grapes aren't purple, but whatever. So I'm gonna write these numbers down with their units. 145 acres, 5.50 grams. So grams for every square meter is grams per square meter. And let's write that as a vertical fraction instead of a horizontal one, because it's just as easy to write a vertical one with your hand. The reason we write them horizontally on PowerPoint slides is because it's a lot easier to type them that way. And then we've got this guy at the end. Let's copy him down too. So one of those is where we're starting. And what are we trying to get to? Kilograms. So kilograms is over here. So in this one, we have to decide, which one do I start with? And sometimes that's hard. Well, let's face it, they rarely give you extra information, because we're really not trying to make this harder than it is. So we're probably going to need to use all of those. One is the starting point, and the rest are actually conversion factors. Could 145 acres be a conversion factor? No, because there's just one unit. This has 2 units, grams per square meter. This is actually written as a unit equation. We just flat out recognize, well, that's a conversion thing there. So this is the only one that can't be used as a conversion factor, so that's probably where we're going to start. Now we need to figure out, how do we get from acres to kilograms? If you try to Google that, you're not going to get a good answer, because there's conversion factors in here that are specific to the problem, and the internet doesn't know what problem you're doing. Well, let's look at what we've got. This conversion factor has acres in it. So if we use that one, we can go from acres to square kilometers. So let's try doing that first. That's all nice. Kilometers squared and kilograms. This is the only thing I've got left. This is grams and square meters. Well, could I take square kilometers to square meters? Yeah, maybe I don't like doing that, but yeah, we do know how to do it. And then this will allow me to convert square meters to grams, and then I can do grams to kilograms. Sometimes it's helpful, you get partway across, you're like, I don't know where to go. Well, start from the other end and work backwards. I have kilograms, and you look at this, oh, well, there's grams. I know I could do kilograms and grams, and so you might work backwards. Okay, but that's the hard part. Okay, now we're going to write all this out. I am going to erase this guy because he is also written right up there. 145 acres. And I have, well, this arrow lost its arrow. 1, 2, 3, 4. 1, 2, 3, 4. Here's Dora chanting with the map, acres to These are what we write down here. Just copy them down. This unit goes in the bottom. Accidentally paused it again. Sorry, YouTube people. Once you get the path written out, count the arrows, that's how many fractions, write the units on the top, take the first unit, put it in the bottom of the next, cancel those out, just go across, put all the units in. Okay, it's the same every time. Now we'll put in our numbers. And you don't have to do the first one first and go through to the end. You can do whatever you want. If you recognize one and think it's easy, go ahead and do that one first. It's like, oh, kilograms to grams, that seems easy. Oh, look, I put the answer up there. Well, what does kilo stand for? 10 to the plus 3. So I've got kilo on one side, 10 to the 3 on the other side, never put them together. 1 kilogram is 1 times 10 to the 3rd grams. And the rest of these look kind of icky. Well, what's this guy? This is grams and square meters. So that's this one right in here. So grams had the 5.50 and the meters didn't have a number. If you really want there to be a number, it's going to be 1. And then this one, those 2 units fit with this guy. So 1 square kilometer, 247 acres, because they gave that to us. Then we need to do this squared thing. So let's just make a little note to ourselves off to the side here. So I've got kilometers, and I'm going to meters. Kilo means 10 to the 3. This is squared, so I have to square the whole thing. So 1 square meter equals, what's 10 to the 3 squared? It's 10 to the 6. If you can't do that in your head, that's fine. You just need to know how to tell your calculator to do that. Oh, do you see what I did wrong? I lost the K. That's not good. There we go. That was a close one. Especially when you're just beginning this, it's a good idea to write that out and actually square the number here before you go sticking it in here. So 1 square kilometer is 10 to the 6 square meters. And now we just need to calculate. 145 times 1 divided by 247 times 1 EE6 divided by 1 times 5.50 divided by 1 times 1 divided by 1 EE3 equals. I'm running out of space. Without looking at the answer that I accidentally popped up on the top. How many sig figs? 3. So the first number that we started with, that was 3. And I'll give you a hint. Most of the time, your answer is going to have the same number of sig figs as the number you started with. But not always. But, you know, if you're just like, I can't sig fig today, just go with that. Or if it's really bad, 3 or 4. Usually, 3 or 4 sig figs is good. And in my opinion, more is better than not enough, because you can always round them off at the last minute. But if you don't write down enough, you have to do the whole calculation again. So 3 sig figs would be right there. So again, we're rounding off in these large decimal places, so we should put it in scientific notation so we don't accidentally change the value. So 3.2, and this 2, I'm going to have to round up to 3 because of the 8. Times 10 to the something, 1, 2, 3, 10 to the 3. Big number, positive exponent, and the unit is kilograms. One way to make use of the lecture videos that are available is to just go quick through it if you don't need to hear all the talking again. Just go to the point where I put the problem up and pause it, and then try to do it yourself. And maybe you get stuck. Well, press play until you've heard just enough that you know what to do next. And then do that and keep going until, maybe you finish the problem, maybe you get stuck again. But that way I can kind of hold your hand while you do the problem, even though we're not anywhere close to each other. Oh, I said one more, I lied. We have to do this one too. Density is a conversion factor. So there is an equation for density. Density equals mass over volume. We are only going to use that when we're calculating the density. If we're using density for any other reason, we're not going to use D equals M over V. We're not going to use that triangle thing or rearrange it or anything, because that's a disaster for most people. So I'm going to show you how to use density as a conversion factor. So here's the density, 0.710 grams per cubic centimeter. It's just a conversion factor between grams and cubic centimeters. And so just like with the previous problem where we had grams per square meter for the fertilizer, we're just going to use it as a conversion factor. So backpackers often use canisters of white gas to fuel a cooking stove's burner. If one canister contains 1.45 liters of white gas and the density of the gas is 0.710 grams per cubic centimeter, what is the mass of the fuel in kilograms? Okay, we've got volume, and we've got a density, and we're supposed to find kilograms. So we write the numbers down. 1.45 liters, 0.710 grams. That's a fraction. Make it look like a fraction. And then I'm trying to get to kilograms. Which one of these do I start with? The first one. This one is not a conversion factor. So this one's probably going to be used as a conversion factor. The only thing I can do with that one is start. So liters to something, and there's a something to kilograms. Now they gave us this grams to cubic centimeters, but my beginning and end are totally different from that. Is one of these units similar to my beginning or end? Centimeters cubed is a volume which is related to liters, right? Do you know how many centimeters cubed are in a liter? What if we call this milliliter instead? That helps, huh? Yeah. Can we do that? Yeah, we can. Cubic centimeter and milliliter, same thing. Two different names for the same thing. Okay? So we could go from liters to milliliters. This gets us between grams and milliliters, right? Can we go from grams to kilograms? Sure. Ta-da! .45 liters. There's 3 arrows, 3 fractions. Liters to milliliters to grams to kilograms. this unit comes down here, so those are going to cancel out. This one comes down here, so those. This is the same thing I've been doing all day long. All the units. Now I go for numbers. Maybe this time I want to use that density first because it's just sitting there. So that's the grams and milliliters one because that's the units I've got over there. So 0.710 grams for every 1 milliliter. Milliliters and liters. Well, that's just a metric prefix deal. So milli is on the top, and milli means 10 to the minus 3. So I don't put milli and 10 to the minus 3 together. Yes, question?
So it says centimeters cubed. Do you just put milliliters, or do you have to put milliliters cubed? You can just put milliliters and drop.
It's just milliliters, because milliliter is already a unit of volume.
So you
And
can-
if you cube that, I don't know what dimension that goes
Oh.
into.
Okay.
Yeah, right? That's tempting though. Yeah, good question. I thought you were gonna tell me I was doing something wrong.
So it would be like, cubing it already a square foot cube.
Yeah, you just, it doesn't have a physical meaning,
Okay.
yeah. And there are people who love to think about stuff like that. I'm not one of them.
Is that the only, I guess you could say thing that would do
Well,
that?
I mean, you can't square time, can you?
You can.
Or temperature. So really, length is the only thing that you can square and cube. Never thought about it that way before. Interesting. Because there's 3 dimensions of space, but there's not 3 dimensions of time. At least not that we know of. Yes?
For this one, can I use the formula, like the density equal to the mass over the volume? And I
You can, but don't let me see you. So on today's worksheet, there's a problem or two where density can be used as a conversion factor. I want you to try using it as a conversion factor. If you are calculating a density, you have to use the density equation. Okay? But after you show me that you can do it as a conversion factor, after that, you can do whatever you want as long as you come up with, the right answer. A lot of people have very strong disagreements with algebra, right? It's just like, it was some mysterious thing and things go on the top and the bottom and you're like, I don't know how they did that. Well, this is a way that you can avoid even thinking about that. But some people like algebra. So after today you can do that, but not today. So here, again, another just prefix thing. I've got prefix on the top, I put what it means on the bottom. And then I'm ready to do my calculator. 1.45 times 1 divided by 1, negative 3 times 0.710 times 1 divided by 1, 3. My calculator didn't show me a big mess, so I just wrote all of it down. How many sig figs? 3. Our starting number had 3. Our density also had 3. Density is measured, it doesn't have infinite sig figs. 1.03 kilograms. There are some problems, including some on the worksheet, where you have to use equations, and then sometimes equations and unit conversions together. But still, you're going to start by looking at what am I given and what am I trying to find. And I think you're all tired of listening to me talk, so there. Chapter 1 is done.